April 7th, 1945, 06:45 hours, Tokyo Bay. The first rays of dawn strike Mount Fuji's snow-capped peak as 91 silver shapes slice through the morning air at 25,000 feet. North American P-51 Mustangs, sleek, fast, utterly impossible, banking into formation with the casual confidence of aircraft that have fuel to burn and nowhere they cannot reach. Below, air raid sirens wail across the Japanese capital. Pilots sprint across muddy airfields, pulling on flight gear as ground crews frantically drag camouflage netting from fighters that haven't flown in days, sometimes weeks, due to fuel shortages, engine failures, missing parts. The scramble is chaos, desperation. More than 100 Japanese interceptors claw skyward from airfields around Tokyo. Kai-84, Hayates, Kai-43, Hayabusas, A6M Zeros, N1K2J Shidens. The best fighters Japan has left, flown by pilots who've been told the same thing for 4 years. The ocean protects us. The distance is our shield. American fighters cannot reach the homeland. Then they see them. Single-engine fighters. Not Navy Hellcats from carriers with 200-mile combat radii. Not twin-engine P-38 Lightnings stretching their range to the breaking point. Land-based, single-engine Army fighters, gleaming in parade formation over the Emperor's Palace, 750 miles from their base, flying as if they own the sky. Flight Sergeant Toshio Anazawa, climbing hard in his Kai-84, feels his stomach drop. His altimeter reads 18,000 feet. His engine is already gasping on 87-octane fuel, cylinders misfiring, manifold pressure fluctuating wildly. Above him, the Mustangs sit at 25,000 feet, their Packard Merlins breathing easily. Superchargers seamlessly feeding compressed air into cylinders machined to tolerances his mechanics can no longer achieve. This is impossible. The thought hammers through every Japanese pilot's mind as they gain altitude. Their commanders had assured them, promised them, that no American fighter could cross 750 miles of open ocean, escort bombers, engage in combat, and still make it home. The fuel calculations alone made it absurd. The navigation over featureless water, suicidal. The reliability required of a single engine for 4 hours over the Pacific. Fantasy. Yet there they are. Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy, knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the story. Not struggling, not conserving fuel, not turning back. Hunting. Captain Yasuhiko Kuroi, a veteran with 200 combat hours, keys his radio. All units, enemy fighters confirmed over the capital. Repeat, single-engine fighters over Tokyo. His voice cracks on the last word. He has seen Zeros dominate the Pacific, seen the tide turn at Midway, watched the slow grind as American industry buried Japanese courage under mountains of steel. But this is different. This is the moment the ocean stops protecting Japan. The Mustangs drop their 110-gallon auxiliary tanks. Silver cylinders tumble earthward, glinting in the sun, exploding across rice paddies and village streets. The drop is casual, practiced, the international signal that the escort phase is over and the killing phase has begun. No hesitation, no concern about fuel. They've crossed an ocean and still have gas to fight. Below, in the streets of Tokyo, civilians look up. They see contrails cutting across the sky above their homes. Not the high, distant scratches of B-29s at 30,000 feet, but the tight, aggressive spirals of dogfighting aircraft. American aircraft, over the Emperor's capital, over the heart of the empire that was supposed to be unreachable. Warrant Officer Sadamu Komachi, wrestling his Zero into a climbing turn, thinks, if they can do this, if they can bring fighters here, then what can't they do? The answer, he will learn in the next 20 minutes, is nothing. The age of distance as defense ended at dawn. The mathematics of industrial war had arrived over Tokyo, and mathematics doesn't negotiate. Very long range, VLR. Fighter operations, April 1945. The mission profile read like science fiction to pilots who trained in 1942. Takeoff from Iwo Jima at 5:30 hours. Climb to 10,000 feet over open ocean. Fly 660 nautical miles, 750 statute miles, on a compass heading with no landmarks, no alternate airfields, nothing below, but Pacific swells. Rendezvous with B-29 formations over Tokyo, precisely at 700 hours. Escort through defended airspace. Engage enemy fighters, then fly 750 miles back. Total mission time, 4 hours, 15 minutes. Every aviation engineer in 1943 would have called it impossible. The numbers were brutal. A typical fighter at combat power burned 150 gallons per hour. 4 hours of flight meant 600 gallons minimum. Most fighters carried 250 gallons internally. The math didn't work. It couldn't work. Which is exactly what Japanese military planners concluded when they calculated American fighter ranges and declared the homeland safe from single-engine escorts. They were working with 1943 mathematics. America was flying 1945 physics. The Packard F-1657 Merlin engine changed everything. At economical cruise settings, 250 SOPT RPM, 31 inches of manifold pressure, it consumed just 65 gallons per hour, while pushing the P-51D at 200 km true airspeed. This wasn't theoretical. This was production line reality, replicated across 15,586 aircraft, with quality control that actually improved as manufacturing scaled up. The Merlin's two-stage, two-speed supercharger was the secret. Unlike Japanese single-stage designs that lost power above 20,000 feet, the Merlin's second stage kicked in automatically at altitude, compressing thin air efficiently without guzzling fuel. The engine breathed easily where Japanese power plants suffocated, and did it while sipping gasoline like a long-distance cruiser, not a fighter. But fuel efficiency alone wouldn't bridge 750 miles of ocean. Enter the laminar flow wing. North American Aviation's engineers, led by aerodynamicist Edgar Schmude, designed a wing that maintained smooth airflow over 60% of its surface, compared to 30% on conventional airfoils. The result, 35% less drag. In practical terms, this meant the P-51D could fly farther on the same fuel, or carry more fuel and still outperform competitors. The wing wasn't just aerodynamically elegant. It was a force multiplier that turned range from a weakness into a strategic weapon. Add the external fuel system. 2 110-gallon drop tanks hung under the wings, feeding into the main system through pressure-balanced lines. Total fuel load, 489 gallons. Enough for 7.5 hours at cruise, with reserves for combat power, evasive maneuvers, and headwinds. When the tanks emptied, pilots jettisoned them with a cockpit lever. Weight gone, drag gone. Combat performance restored instantly. Navigation over 750 miles of featureless ocean relied on dead reckoning, radio compass, and timing so precise, it bordered on arrogance. Pilots calculated fuel burn, wind drift, and compass variation, then bet their lives the math was correct. No GPS, no radar navigation, just airspeed, heading, elapsed time, and the knowledge that if they missed Iwo Jima on the return leg, the next stop was the ocean floor. The reliability requirement was equally insane. One engine, 4 hours over water. Engine failure meant ditching, and Pacific rescue rates were grim. Yet the Merlin proved so reliable that abort rates stayed below 5%. American production tolerances, quality steel, precision machining, and 100-octane fuel meant engines that didn't quit. Japanese intelligence analyzed captured P-51s and reached the correct technical conclusion: theoretically possible. But their commanders reached a different conclusion: logistically impossible. No nation, they reasoned, could supply 100-octane fuel in the quantities required. No air force could maintain such complex aircraft so far from home. No pilots could execute such navigation reliably. They were half right. No nation except America could do it, and America was doing it daily. 655 hours. Airspace over Honshu. Altitude 18,000 to 25,000 feet. They rise from a dozen airfields scattered across the Kanto Plain: Chofu, Yokota, Kasumigara, Atsugi. More than 100 fighters clawing skyward in the largest defensive scramble Japan has mounted in months. The formation is a desperate assembly of everything the Imperial Japanese Army and Navy can still put in the air. Nakajima Ki-84. Hayats, the Frank, Japan's fastest and most modern fighter, theoretically capable of 427 mm with perfect tuning and high-octane fuel. Pilots nursing temperamental Homar engines that misfire above 20,000 feet, watching manifold pressure gauges fluctuate wildly, praying landing gear struts don't collapse on return. Nakajima Ki-43. Hayabusas, the Oscar, lightweight, maneuverable, pitifully armed with just two 12.70mm machine guns. Fast in turns, but fragile, their thin aluminum skin offering no protection against 50 caliber rounds that punch through like tissue paper. Nakajima Ki-44 Shokis, the Tojo, brutish interceptors built to kill bombers, not dogfight. Heavy, fast in dives, already obsolete against American fighters that can outclimb, outrun, and outgun them. Kawasaki Ki-61, Hiens, the Tony, sleek inline engine fighters that look modern but suffer chronic cooling problems. Engines overheating, glycol leaks, propeller pitch mechanisms jamming at the worst possible moments. Mitsubishi A6M Zeros, once the terror of the Pacific, now flying coffins flown by teenagers with 50 hours of training. No armor, no self-sealing tanks. One incendiary burst, and they torch like paper lanterns. Kawanishi N1K2J Shidens, the George, Navy fighters that are genuinely excellent when they work, which is less than half the time. Complex, maintenance-intensive, available in numbers so small they're statistical noise. Flight Lieutenant Naoshi Kano, leading a chutai of Ki-84s from the 47th Sentai, scans the sky above him. His altimeter reads 19,500 feet. His engine is already laboring, cylinders missing, power dropping. The Mustangs sit 5,000 feet higher, silver specks backlit by the rising sun, flying lazy S-turns to stay with the B-29 formation. His radio crackles. All units, enemy fighters confirmed, single engine, Army type, over the capital. Kano keys his mic. Say again, single engine? Confirmed, P-51 type, approximately 90 aircraft. Impossible. The word echoes through cockpits across the defensive formation. Pilots glance at fuel gauges, calculating distances, doing math that doesn't work. Iwo Jima to Tokyo, 750 miles. No fighter flies that far. Not Japanese, not American, not anyone. Then Captain Takeo Tanemisu sees them with his own eyes. Not distant, not fleeing, not conserving fuel, dropping their wing tanks. Silver cylinders tumble from beneath Mustang wings as the formation crosses the Honshu coastline. 110-gallon tanks glinting in morning sun, tumbling end over end, exploding across rice paddies in white blossoms of aviation gasoline. The jettison is synchronized, casual, theatrical. 91 fighters simultaneously declaring, "We have fuel to burn, we're ready to fight, and we're not going anywhere." Tanemizu's breath catches. They've already flown 750 miles, and they're jettisoning fuel. The Mustangs tighten their formation. Finger 4 combat spread. Speed, 350 more indicated. Altitude, 25,000 feet. Engines purring at cruise power. Superchargers feeding compressed air into cylinders that don't misfire, don't overheat, don't quit. Pilots with 600 hours of training. Oxygen systems that work. Radios that transmit clearly. Gun sights calibrated to milliradians. Below them, Japanese pilots struggle upward through thickening air. Engines coughing. Radios crackling with static. Some pilots already hypoxic at 22,000 feet. Oxygen systems failures. Leaking connections. Empty bottles. Vision tunneling. Reaction times slowing. The altitude gap is 5,000 feet. In energy terms, it's everything. Warrant Officer Saburo Sakai, a surviving ace with one eye and reflexes honed over 4 years of combat, understands immediately. They have altitude, they have speed, they have fuel. We're already dead. We just don't know it yet. The Mustangs roll inverted and dive. 6:58 hours. The engagement begins. The Mustangs dive from 25,000 feet at 450 meters, 100 mat faster than anything in the Japanese formation can achieve in level flight. Physics dictates the outcome before a single round is fired. Kinetic energy equals 1/2 mass times velocity squared. The Americans carry speed, altitude, and momentum. The Japanese carry desperation. First contact, 6 seconds. Lieutenant Robert W. Moore locks onto a Ki-43 Hayabusa, climbing at 180 mph. Moore's Mustang is diving at 420 mph, a 240 mid-closure rate. The Japanese pilot never sees him. Moore's gunsight Pipper settles on the Hayabusa's engine cowling. Range, 300 yards. He squeezes the trigger. 6 M2 Browning. 50 caliber machine guns erupt simultaneously. 4,800 rounds per minute. 80 rounds per second. Each armor-piercing incendiary round weighs 46 grams, travels at 2,900 feet per second, delivers 18,000 joules of kinetic energy on impact. The mathematics are clinical. A 2-second burst sends 160 rounds downrange. 12 hit the Hayabusa. The thin aluminum skin offers no resistance. Rounds punch through engine block, fuel tank, cockpit. Incendiary compounds ignite gasoline vapor. The Ki-43 explodes. Elapsed time from trigger pull to fireball, 2.3 seconds. Moore pulls up, climbs back to altitude, retains his energy advantage. The Japanese pilot never fired a shot, never maneuvered, never knew death was coming at 240 minutes impure closure. This is not a dogfight. This is a massacre conducted by slide rule. Across the engagement zone, the pattern repeats. Mustangs diving. Japanese fighters, Ki-84s, Zeros, Ki-44s, attempting to turn, climb, evade. But evasion requires energy they don't have. Their engines, starved of oxygen above 20,000 feet, produce 60% of rated power. Single-stage superchargers can't compress the thin atmosphere. Cylinders misfire on 87-octane fuel. Propellers can't bite efficiently. Pilots wrestling controls, feeling aircraft mush as speed bleeds off. Stall warnings screaming. The Mustang's Packard Merlins produce full power at 25,000 feet. 2-stage superchargers, feeding compressed air into precision-machined cylinders, burning 100-octane fuel. The Americans fight in an altitude band where Japanese aircraft barely function, and when Mustangs dive, they accelerate past 450 mph, while Japanese fighters redline at 380 mph in perfect condition. None of these aircraft are in perfect condition. Captain James Tapp latches onto a Ki-84, theoretically Japan's best fighter. On paper, it can dogfight a Mustang. In reality, the Hayate's Homar engine is misfiring. Landing gear indicator, showing hydraulic failure, oil pressure fluctuating. The pilot is 19 years old with 47 hours total flight time, barely enough to solo safely, let alone survive combat against a pilot with 600 hours and 30 missions over Germany. Tapp has fought FW-190s and BF-109s. aircraft designed by the world's best engineers, flown by Luftwaffe veterans. This Ki-84 flies like a training aircraft with engine problems, because that's exactly what it is. He closes to 200 yards, fires a 3-second burst. The Ki-84's engine disintegrates. The propeller tears free, tumbling through space. The pilot attempts to bail out, but his parachute has been cannibalized for parts, something TAP will never know, never understand. The Hayate enters a flat spin, impacts a hillside at 300 mm. Another equation solved. By 7:15 hours, 17 minutes of combat, the mathematics are irrefutable. 21 Japanese aircraft destroyed. 91 Mustangs still airborne. 0 American losses. The kill ratio, 21:0. When one Mustang later goes down to ground fire, it becomes 21.1. Later missions will refine the arithmetic. 13:1, then 20:1, then 30.1. Japanese pilots aren't cowards. They're flying degraded aircraft on synthesized fuel with training measured in weeks against Americans flying precision-engineered machines with training measured in years. Courage is abundant. Engine tolerances are not. Training hours are not. Quality steel is not. 100-octane fuel is not. Flight Sergeant Yasuo Kuwahara, one of the few survivors, will write, "We did not lose because we lacked bravery. We lost because they could build 10 Mustangs for every fighter we produced, and every one of theirs worked." Industrial capacity times engineering, precision equals air superiority. The equation admits no appeals to honor. The war Japan was already losing before the first Mustang arrived. While American P-51s burned 100-octane aviation gasoline refined in Texas and California, fuel specifically formulated for high-compression engines operating at maximum performance, Japanese pilots made do with whatever could be scraped together from domestic production and coal synthesis. 80 octane, sometimes 87, often lower. The octane rating measures fuel's resistance to pre-ignition, its ability to withstand compression without detonating prematurely. High-performance engines require high-octane fuel. The Nakajima Homar engine in the Ki-84 was designed for 92 octane minimum. Fed 80 octane, cylinders detonated before spark plugs fired, destroying pistons, cracking cylinder heads, burning valves. Engines that should have produced 2,000 horsepower struggled to maintain 1,400. Some units, desperate, mixed pine root oil extracted from stumps, alcohol distilled from sweet potatoes, even sake production byproducts into aviation fuel. Pilots reported engines that wouldn't start, ran rough at all power settings, and quit mid-flight without warning. But fuel was only the beginning. The steel told the real story. American P-51 landing gear struts were forged from chromium-molybdenum alloy steel, heat-treated to precise specifications, tested to failure points, installed with quality control that rejected components for microscopic flaws. Japanese landing gear struts in late 1945 were manufactured from whatever steel remained, often containing impurities that made proper hardening impossible. Blast furnaces damaged by B-29 raids. Chromium supplies exhausted, alloying elements unavailable. The result, landing gear that collapsed on touchdown. Not occasionally, routinely. Pilots completing combat missions successfully died when their aircraft's legs buckled on landing, slamming fuselages into runways at 80 mm. Writing off aircraft Japan could not afford to lose. Maintenance crews learned to examine struts visually before every flight, looking for hairline cracks, knowing that even good struts might fail, because the metallurgy was fundamentally compromised. Engine manufacturing faced identical degradation. The Homar's 18 cylinders required precise tolerances. Piston clearances measured in thousandths of an inch, bearing surfaces machined smooth, metals pure enough to withstand thermal stress. By 1945, Japanese factories produced engines with rough machining, impure aluminum castings, steel containing slag inclusions. Engines leaked oil, overheated, seized without warning. When engines failed, there were no spare parts. B-29 raids had destroyed machine tool factories, bearing manufacturers, propeller plants. The supply chain collapsed. Maintenance crews cannibalized crashed aircraft for parts, pulling engines from wrecks, salvaging instruments, stripping usable components. Entire air groups operated with 60% of aircraft grounded awaiting parts that would never arrive. A Ki-84 unit might have 40 aircraft assigned and 12 operational. But Japan's most catastrophic loss wasn't material. It was human. The instructor corps, veteran pilots with thousands of hours, the men who could train the next generation, died in 1942 and 1943, at Midway, at Guadalcanal, in the Solomons. Japan rotated its best pilots to frontline units continuously, grinding them down in attritional combat until combat experience became a death sentence rather than an asset. America rotated veteran pilots home to train new pilots. Combat experience transferred to students who learned from survivors, not corpses. By April 1945, Japanese replacement pilots arrived at operational units with 50 hours total flight time, barely enough to take off and land safely. Some had never fired their guns in flight. Many had never flown in formation. Few had practiced high-altitude operations or oxygen system management. American replacement pilots arrived with 600-plus hours, including gunnery training, formation flying, navigation, instrument flying, combat tactics, emergency procedures. The disparity was existential. Lieutenant Toshimitsu Imaizumi, age 19, flight time 47 hours, flew his first combat mission on April 7th. He faced pilots like Captain James Tapp, 600 hours flight time, 30 combat missions over Europe, veteran of engagements against Luftwaffe aces. Imaizumi lasted 90 seconds. The war was already over. The combat was just mathematics catching up to reality. Japan had gambled on a short war and lost the moment it became a long one. Iwo Jima, 0400 hours, April 7th, 1945, 4 hours before first contact. While pilots sleep, a different war is already won. Fuel trucks, dozens of them, roll across Iwo's volcanic ash runways in the pre-dawn darkness, pumping 100-octane aviation gasoline into P-51 wing tanks. Each Mustang takes 269 gallons internal, plus 220 gallons in external drop tanks. 489 gallons per aircraft. 91 Mustangs flying today's mission, 44,599 gallons consumed before the first engine starts. Add the fuel burned by B-29s, by transport aircraft, by patrol planes, by the previous day's missions and tomorrow's sorties. A single VLR fighter mission to Tokyo consumes 57,000 gallons minimum, enough to fuel every vehicle in a mid-sized American city for a week, and America delivers it without hesitation. Liberty ships, the mass-produced workhorses of the U.S. Merchant Marine, crossed the Pacific loaded with aviation gasoline in 55-gallon drums, sealed tankers, bulk storage containers. Each ship carries 10,000+ tons of fuel. They sail in convoys protected by destroyers, arrive at Iwo Jima, Saipan, Tinian, offload millions of gallons monthly. The fuel comes from Texas refineries, California crackers, Oklahoma wells, a petroleum infrastructure so vast that supplying the entire Pacific theater represents less than 15% of total U.S. production capacity. Japan, meanwhile, synthesizes fuel from coal tar and pine roots. The war is over before it begins. But logistics isn't just fuel. At 0530 hours, ground crews complete pre-flight inspections. They check engine oil levels, replenished from abundant stocks, coolant systems, glycol shipped by the ton, hydraulic fluid, never in shortage, oxygen bottles, filled from liquid oxygen plants running continuously, Ammunition belts, thou 280 rounds per aircraft, loaded fresh. Radio sets, tested, frequencies set, crystals replaced if needed. Gun cameras, film loaded. Navigation instruments, calibrated. Life rafts, inspected. CO2 cartridges replaced. American maintenance ready rate, 80%. 80% of P-51s assigned are flyable at any given moment. Spare parts arrive weekly. Propellers, engine components, hydraulic pumps, radios, instruments. When an engine reaches its service life, it's swapped for a fresh one in 6 hours. When a radio fails, another is installed from stock. Quality control ensures replacement parts fit perfectly, function reliably. Japan's maintenance ready rate, 20%. 4 out of 5 Japanese fighters sit grounded awaiting parts that will never come. Engines that can't be repaired. Instruments cannibalized from crashed aircraft. When a Homar engine fails, there's no replacement, just an empty aircraft, serving as a parts donor for the few still flying. At 05:45 hours, pilots strap in. They wear fleece-lined leather flight suits, heated electrically. Oxygen masks connected to tested regulators. G-suits that inflate automatically during high-G maneuvers, preventing blackouts. Parachutes inspected monthly. Life vests, survival kits containing flares, dye markers, fishing line, water purification tablets, first aid supplies, signal mirrors. Japanese pilots wear whatever they can scrounge. Oxygen systems fail routinely, leaking connections, empty bottles, faulty regulators. Many fly hypoxic above 20,000 feet, vision tunneling, reaction time slowing, judgment impaired. No G-suits exist. Parachutes are often cannibalized for parts or left behind to save weight, knowing there's no rescue infrastructure anyway. Radio discipline tells the story most clearly. American formations communicate constantly. Target updates, threat calls, formation adjustments, damage reports. Radios work. Frequencies are clear. Every pilot hears every transmission. Japanese formations fly half-blind. Radios fail. When they work, they're jammed by American electronic warfare. Pilots can't coordinate, can't warn each other, can't adjust tactics. They fly visual formations in radio silence, hoping hand signals suffice. At 6:30 hours, 91 Mustangs taxi for takeoff. Engines start reliably, instruments read accurately. Radios check in clearly. Fuel gauges show full tanks. This is the real weapon, not the Merlin engine, not the laminar wing, not the 50 caliber guns. The logistics chain that ensures everything works, every time, without question. Japan fights with courage. America fights with Liberty ships full of gasoline, warehouses full of spare parts, and supply chains that never stop. Courage cannot compete with that. Industrial Logistics wrote the ending long before the first shot was fired, April 16th, 1945, 9 days after the first Tokyo raid. Weather forecast, clear skies. The forecast was catastrophically wrong. At 14:30 hours, 150 P-51D Mustangs from the 15th, 21st, and 506th Fighter Groups departed Iwo Jima for another VLR escort mission to Tokyo, 750 miles of open ocean, 4 hours over water. The routine that had become almost casual in its execution. Pilots checked weather reports showing favorable conditions, scattered clouds, light winds, visibility unlimited. The Pacific had other plans. At 15:45 hours, 100 miles north of Iwo Jima, the formations encountered something meteorologists hadn't predicted, radar hadn't detected, and intelligence hadn't warned about. A rapidly intensifying frontal system spanning 200 miles, rising from sea level to 35,000 feet, with embedded thunderstorms producing turbulence violent enough to tear aircraft apart. There was no way around it, no way over it. Fuel calculations allowed no margin for detours. The mission was already at maximum range. Turn back or press through. Flight leaders made the decision pilots had made for 4 years. Press on. The first Mustangs entered the storm wall at 15:47 hours. Visibility dropped to 0 instantly. Rain hammered aluminum skin like machine gun fire. Lightning arced between cloud layers, blinding pilots through canopies, interfering with instruments, turning cockpits into strobing chaos. Turbulence slammed aircraft up and down with 4G jolts, positive 4Gs, then negative 3Gs, then positive again, stomachs lurching, instruments spinning, altimeters unwinding, airspeed indicators fluctuating wildly. Pilots fought controls with both hands. Artificial horizons tumbled, useless. Magnetic compasses swung erratically. Radio calls devolved into static and screaming. Formations disintegrated. Each pilot alone in churning grey violence, flying instruments they could barely read, trusting gauges that contradicted each other. Lieutenant Thomas Maloney's airspeed indicator read 220 metomp, then 180, then 310, then 150. His altimeter showed 8,000 feet descending, but he felt G-forces indicating a climb. His turn coordinator said wings level, but his inner ear screamed 60-degree bank. Spatial disorientation, the killer of instrument pilots. The phenomenon that makes experienced aviators fly perfectly functional aircraft into the ocean because their brain insists the instruments are lying. Maloney's P-51 entered a graveyard spiral. He never realized it. His Mustang hit the Pacific at 400 metomp, wings level in his mind, actually inverted in reality. Impact time, 15:51 hours. No distress call, no ejection attempt, just another aircraft that stopped transmitting. Across the formation, the horror repeated. Pilots losing spatial orientation. Aircraft entering uncontrolled descents. Some recovered at 2,000 feet, engines screaming, airframes groaning under G-loads. Some didn't. P-51s emerged from cloud bases inverted, spinning, wings overstressed, pilots unconscious from hypoxia induced by violent altitude changes. Lieutenant Robert Quinn's engine ingested so much water it flamed out at 12,000 feet. He attempted a restart. The procedure worked in training, should work now. Propeller windmilling, fuel mixture rich, magnetos on, battery master on, hit the starter. Nothing. The Merlin, the engine that never quit, the power plant so reliable pilots joked it was immortal, refused to restart. Quinn ditched at 15:59 hours, 150 miles from Iwo Jima, 600 miles from Tokyo, in seas running 15-foot swells. His life raft deployed. His radio transmitted for 6 minutes. He was never found. By 16:15 hours, the surviving Mustangs broke through the storm's western edge into clear air. Pilots checked in on guard frequency, voices shaking, calling for squadron mates who didn't answer. The count came slowly, painfully. 27 P-51Ds lost, 27 pilots gone. Not to enemy action, not to mechanical failure. To weather that hadn't existed in the forecast, in a mission profile so extreme that a single unforecast storm could kill more Americans than 3 months of Japanese fighter opposition combined. The mission continued. The survivors escorted B-29s over Tokyo. They shot down Japanese fighters. They returned to Iwo Jima. But April 16, 1945, Black Friday, proved what every VLR pilot knew, but rarely spoke aloud. The ocean was still the most dangerous enemy in the Pacific. Even American industrial might couldn't forecast typhoons. Even the perfect fighter couldn't fly through physics. April to August 1945, the death of Japanese air power. After April 7th, the mathematics became inexorable. Every mission deepened Japan's pilot deficit. Veterans died. Rookies died faster. Replacement training collapsed entirely. Flight schools ran out of fuel. Instructors, flyable aircraft. By June, new pilots arrived at operational units with 20 hours total flight time. Some had never practiced aerobatics. Many had never fired their guns. A few had never flown above 10,000 feet. They were children flying sophisticated machines they barely understood, against pilots who'd been fighting since 1943. Life expectancy, 2 to 3 sorties. Lieutenant Minoru Suzuki, age 17, graduated flight school in July with 19 hours logged. His first combat patrol on July 24th lasted 11 minutes. A Mustang appeared behind his Ki-43 Hayabusa during a climbing turn. Suzuki never saw it. 650 caliber rounds hit his engine. His aircraft torched. He bailed out successfully, one of the lucky ones, landing in a river with second-degree burns. He never flew again. There were no replacement aircraft. By July, operational readiness collapsed to single digits. A fighter group authorized 40 aircraft might have 3 flyable. The rest grounded for lack of fuel, parts, ammunition, or pilots capable of flying them. Maintenance crews cannibalized wrecks so aggressively that airfields became graveyards of stripped fuselages, engineless airframes, aircraft with wings removed, tails detached, anything useful scavenged. The fuel crisis became absolute. What little aviation gasoline Japan still produced went to kamikaze units, the Special Attack Corps that offered one-way missions as strategic doctrine. Conventional fighters sat grounded while suicide planes flew. The logic was brutal and unanswerable. A skilled pilot in a fighter might survive 1 mission, maybe 5. A novice pilot in a bomb-laden aircraft could guarantee 1 enemy ship damaged or sunk. Japan chose guaranteed damage over probable survival. Regular fighter units siphoned fuel from damaged aircraft, drained drop tanks from wrecks, mixed automotive gasoline with whatever aviation fuel remained. Engines ran for minutes before seizing. Pilots took off not knowing if they'd have power to land. The Mustangs noticed. By late July, VLR missions encountered almost no opposition. Formations of 100-plus P-51s swept over Tokyo, Osaka, Nagoya, sometimes drawing a handful of defenders, often none at all. Pilots reported flying entire missions without seeing a single Japanese fighter. Some missions became armed reconnaissance. Mustangs strafing airfields, trains, coastal installations, flying at 500 feet with impunity, because there was no one left to challenge them. Captain John Vogt flew 12 missions in August. He fired his guns once, a strafing pass on a parked aircraft. It wasn't a war anymore, he later wrote. It was target practice against a nation that had nothing left to fight with. On August 14, 1945, the last day of the war, the 506th Fighter Group flew 1 final VLR mission to Tokyo. They encountered 6 Japanese fighters, all Ki-84s. A brief engagement ensued. 2 Ki-84s shot down. 0 American losses. The last aerial combat of the Pacific War ended in a kill ratio that had become depressingly routine. 2-1. At 1200 hours Tokyo time, August 15th. Emperor Hirohito's voice broadcast across Japan, something unprecedented, something unthinkable. The divine emperor speaking directly to his people, announcing surrender. At Atsugi Airfield, Captain Yasuhiko Kuroe sat in his Ki-84's cockpit, engine cold, fuel tanks empty, listening to static-filled broadcasts. He'd survived since 1942, Rabaul, Truk, Iwo Jima, the home islands. He'd watched the empire shrink, watched friends die, watched the sky fill with American aircraft. Japan could no longer contest. He unstrapped, climbed down, walked away from his fighter. He never flew it again. No one did. Japan's Air Force didn't lose a final battle. It simply ceased to exist. By August 15th, fewer than 100 operational fighters remained across all of Japan. Perhaps 200 pilots capable of flying them. No fuel reserves, no spare parts. No training pipeline, no industrial capacity to rebuild. The Mustang had done what strategic bombing, naval blockade, and island-hopping campaigns could not do alone. It made Japanese airspace American airspace. The age of the samurai warrior ended not in glorious battle, but in silent aircraft, sitting on empty runways, flown by ghosts. The equation that decided the Pacific War was written in factories, not cockpits. By August 1945, the mathematical reality was undeniable. The P-51 Mustang had transformed American air strategy from costly attrition into systematic annihilation. What began on April 7th as a shocking demonstration of range became, by summer, routine dominance so complete that B-29 superfortresses stopped bringing fighter escorts on many missions. Not because escorts weren't available, they were abundant, but because Japanese opposition had mathematically ceased to exist. The bombers flew alone over Tokyo in broad daylight, unopposed, dropping incendiaries that turned cities into ash. The Mustang had made this possible not through individual heroism, but through industrial arithmetic applied at scale. The production numbers tell the story with brutal clarity. United States, 15,586, P-51, Mustangs manufactured, all variants. Japan, 3,514, Nakajima, Ki-84, Hayats manufactured, total production. North American Aviation's factories in California and Texas produced more Mustangs in 8 months than Japan produced of its best fighter in 2 years. At peak output, a new P-51 rolled off American assembly lines every 47 minutes. Meanwhile, Japanese factories, bombed, starved of materials, lacking precision tooling, struggled to complete 3 Ki-84s per day. But raw numbers only begin the equation. Of those 15,586 Mustangs, most were built to consistent quality standards that actually improved as production scaled. Interchangeable parts, reliable engines, tested systems, quality control that rejected components for microscopic flaws. Of those 3,514 Ki-84s, perhaps half were truly combat-capable at any given time. Engines failed, landing gear collapsed, fuel systems leaked. Quality deteriorated so badly that pilots never knew whether their aircraft would survive landing, much less combat. Technology, ex-production, ex-training, air superiority. American pilots arrived at operational units with 600-plus hours of flight time, having trained on aircraft functionally identical to what they'd fly in combat. Replacement aircraft arrived continuously. Spare parts never ran out. Fuel flowed without interruption. When an engine reached its service life, a fresh one was installed in hours. Japanese pilots arrived with 20-50 hours of flight time, often having never practiced formation flying, gunnery, or high-altitude operations. Replacement aircraft arrived sporadically, if at all. Spare parts were scavenged from wrecks. Fuel was synthesized from pine stumps. When an engine failed, the aircraft became a parts donor. The war ended, but the arithmetic persists in museums worldwide. Today, only one Nakajima Ki-84 Hayate survives. A restoration pieced together from fragments, displayed in Japan as a reminder of what was lost. No flyable examples exist. The tooling is gone. The factories are rubble. The engineers are dead. Today, hundreds of P-51 Mustangs survive, many still airworthy, flying at air shows, owned by collectors, maintained by industries that never stopped existing. The institutional knowledge persists. Parts are still manufactured. Engines are still rebuilt. The aircraft that won the war still flies, because the industrial ecosystem that created it never collapsed. This is the final lesson of the Pacific Air War. Courage is infinite. Industrial capacity is not. Japan bet on warrior spirit, on Bushido, on the belief that superior morale could overcome material disadvantage. Japanese pilots were brave, extraordinarily brave. They flew obsolete aircraft on insufficient fuel with inadequate training, and they died by the thousands, defending a cause already lost. But bravery cannot machine precision engine tolerances. Honor cannot synthesize 100-octane fuel. Samurai tradition cannot manufacture ball bearings under B-29 bombardment. America bet on factories, logistics, training pipelines, and quality control applied at industrial scale. The bet paid off in kill ratios of 20-1, then 30-1, then infinity. When Japanese fighters stopped rising to meet American formations because there were none left to fly. On April 7, 1945, Japanese pilots looked up and saw the impossible: American fighters over Tokyo. What they were actually seeing was the future, a world where wars are won in factories, not skies, and the nation that can build 10,000 perfect machines will always defeat the nation that builds 1,000 flawed ones. The age of the samurai ended over Tokyo Bay. The age of the assembly line had already begun, and it would never end.